So now we are going to solve the right hand limit of this question. So first of all, the right hand limit r is equal to limit x tends 0 plus f of x, and I will be considering h, so limit h tends 0, f of a plus h, and a is 0, so f of h. And what is f of h? F of h is nothing but cos inverse of 1 minus fractional part of h whole square sin inverse 1 minus fractional part of h. So this will be upon fractional part of h minus fractional part of h cube. Now fractional part of h I can simply put it as h for my convenience. Actually it is not equal to, fractional part of a number is not equal to, of an integer is not equal to that integer, it is 0, but for my convenience I am not putting the brackets. So cos inverse of 1 minus h square sin inverse of 1 minus h upon h minus h cube. So if I tend the h to be 0, so this will be 1 minus 0, so cos inverse of 1 is 0, and sin inverse of 1 is pi by 2, and in the denominator I am also getting 0 minus 0 0. So what is making my numerator and denominator to be indeterminate form is this term and this term. This sin inverse does not pose me a threat, so I am substituting this limit h tends 0 for sin inverse. So I'll get a pi by 2 outside, and inside I'll get limit h tends 0 cos inverse 1 minus h square upon h, I'll take common, h 1 minus h square. Okay, so now this is an important step. What I'll do is I will take my cos inverse 1 minus h square to be alpha. So my cos of alpha is equal to 1 minus h square. Okay, so cos inverse 1 minus h square I have taken to be alpha. So pi by 2, this limit will change, just a second. So alpha upon h, I will take it as 1 minus cos alpha root, okay, from here, and then 1 minus h square I can take it as cos alpha, this 1 minus h square. So this h I have taken it as root 1 minus cos alpha, and this 1 minus h square I don't need to take it as cos alpha. I can in here only I can substitute this limit h tends 0 for 1 minus h square. So when h will tend to 0, this will become 1. So I will get 1 minus h square as 1 itself. So how to change the limit when we are changing the variable as alpha? So in order to change the limit, when I was having h tends 0, when my, in this expression, when my h is tending 0, so I am getting my alpha is tending to be cos inverse of 1, and cos inverse of 1 is 0. So when h is tending to be 0, alpha is also tending to be 0. This will be my new limit. So this was my question. So pi by 2 and limit alpha tends 0. So now how to solve this? Alpha upon, one equation. What is that equation? 1 minus cos 2 theta is equal to 2 sin square theta, but here I am having 1 minus cos theta, not 2 theta. So that will be 2 sin square theta upon 2, and here what is theta? It is alpha, it is, and here theta will be theta by 2. Okay, so 2 sin square alpha by 2, and then I am having, what to do next? I can I will try to make this into sine alpha upon alpha form. So when limit alpha tends 0, sin alpha upon alpha will be 1. So in order to proceed with that, limit alpha tends 0, I can take this alpha down. So 1 upon root of 2 sin square alpha by 2 upon alpha square, okay, which is equal to pi by 2. So in order to take this square common, I will divide this by 4 in this root itself, and I will multiply with 4. If I multiply by in the denominator by 4, so this will be 2 upon 4. Alright, so pi by 2 limit alpha tends 0, 1 upon, here I will get root of half. So if this root goes up, that will become root 2, and sin this part I can write it as sin alpha by 2 upon alpha by 2 whole square. This is in a root, so when that root will get cancelled, I will get sin alpha by 2 upon alpha by 2. And if I substitute the limit, so limit will get substituted here and here, so I will be getting pi by 2 root 2 upon 1. Alright, now you can get confused at this moment that how this is 1, because in the formula which we have learned, limit x tends 0, sin x upon x is equal to 1, but here we are having x, and here we are having x by 2 and x by 2, so that's not a problem. If you are taking half of that variable, then also it will be tending to same 1 itself, so this becomes 1, and you are having root 2 will be cancelled. Your right hand limit is pi by root 2. So in the question we had been asked to find 32 upon pi square L square plus R square. So we know our R to be pi by root 2 and our L was half. So when I substitute this, it will become 32 pi square L square, which is 1 by 4, and R square, which will be pi square by 2. So this will come 32 upon pi square, LCM 4, 1 plus 2 pi square. So this will be 2 and this will be 16, and here 8. Just a correction here, in the last video, in the last part, I had told that the left hand limit is half. That was a silly mistake. Here when this is the left hand limit, this will be 1 when I substitute limit for sin inverse h upon h, and when I substitute the limit here, it will become half. So in this, and this part will be half, but here this won't be 1, because when h tends 0, cos inverse of 0 minus 0, cos inverse of 0 is 1. So cos inverse of 0 is actually pi by 2. So cos of pi by 2 is 0, right? So cos inverse of 0 is pi by 2. So this should not be 1, this should be pi by 2. Okay, this should be pi by 2. So I am at last getting pi by 2 into half, which is pi by 4. So my left hand limit was pi by 4, not half. So that pi by 4 square, when I put, I will get pi square upon 16, and when I substitute here 32 upon pi square, if I take LCM 16, and here 8 pi square, 9 pi square upon 16, this 2, I will get the final answer as 18. Thank you.